Hi, welcome back to the Statistic lecturing series. And we are starting a new topic, and this is expected value. So for the expected value, this is the video number 2, is to show us how to find the expected value. From the previous first video, we start to define what is the expected value and how to find it for the discrete and continuous random variables here. Then we progress into how about if you have a function of a random variables, then how do you find the expected value? As you can see here, and we have did some problem. This is a discrete, how to find a random, how to find expected value. And this is the continuous random variable. How do we find the expected value? And then we progress into how about you have the functions of the expected values. So basically you just plug these functions, plug the values of your random variable x, go into the function and find it. And the same way is how about if you have a function for the continuous. So remember the one you always integrate for the continuous random variables, right? And then you you add it when it's discrete. Okay, so the video number 2 is here. We're just going to continue practicing what we did for the expected value. Okay, so let's take a look at this ones here. This one is it's a little bit different. So this one's here, we call this the piecewise functions, right? So we have 3 pieces here. So the f of x is here, right? So f of x will be equal to x if for the x is from the what? From the 0 to 1. And then the f of x is 2 minus x when the x is from the 1 to 2 here. So we want to find the expected value, right? So we are looking for the expected value of x here. So remember, right? So when we try to find the expected value, so basically that's from our definitions here. We said the expected value is you integrate from the domain. And then the f of x, the x times f of x dx is here. So this is our general definition. We defined it from our video number 1. So see here, because they have 2 pieces, so basically we just divide it, separate it into 2 pieces. So the first one, the x is from 0 to 1. So that's why you need to make sure your upper limit and the lower limit is the same. Then you have x times f of x. So what is f of x here? So this is x, right? So don't get confused. This x here is, in fact, is our f of x, right? Okay, now you integrate to the dx. Then you plus the second piece. The second piece is from 1 to 2 here. So, right? So you need to be careful, make sure your limits match. And then now you have x's, right? And then you times 2 minus x dx here. Okay, so now let's take a look here. So this is x times x is x squared. So this one's here, so this is x squared, right? So the integration of x squared is x cubed over 3. Then you have a lower limit and the upper limit. Then plus, and for here, this one's here is what is 2x minus x squared, right? So when you do the integration, 2x will be 2 to the x squared minus x cubed to the what? To the cube, right? Okay. So the 2 to the cube minus over 3, then you put the upper and the lower limits there. So now basically, so this 2 and this 2, you can cancel here. So you just substitute, and what I did here, so this is the 1/3, and then plus, this is the 4 minus 8, 3, and then minus 1 minus 1/3. Okay, so just be careful about your plus and negative sign. And so this one will give you 1 here. Okay, so this example is just like the extension about what we did in video number 1. So even with the piecewise functions, what you can do is just separate into different pieces. And then you take an integration. Just be careful about what is each function they define in different intervals here. Okay, so far what we did is to find the expected value for one random variable here. So now the next thing is here, we say, how about if you have the expected value for more than one variables? Well, so that's exactly the same here, right? So if you have xy, a function of xy, so you just use a joint distribution function for the xy, and you times your function. And because you have xy, so you added what? You add xy's here. So the same things here, right? So if you have exy's here, you just integrate. Oh, here, see here, I made a mistake. Here should be, this one should be, okay, so this is a type arrow. So this should be x and y's here. So it should be the joint. And then you integrate dx df here, right? So the theory number 5 is the same. You know, if you have a linear combination, you can just do it, you know, the inside the expected value for multiple. So for them, you know, several random variables here. Okay, so now so that's just like when we do the calculus, you have the double integration, triple integrations here. Okay, so let's take a look at this one here. So let's say find the joint distribution. You know, the joint PDF fxy is equal to this. I'm looking for the expected value. So I'm looking for the expected value for the gxxy square. So what can we do here? Okay, so just like we did before, the expected value. So this is x to the y cube, right? So it will just be equal to whatever this one's here, the x to the y cube. Then what? Times the PDF. The PDF is 27. This is x plus 2y. And then you do dx dy here, right? So you can do dy dx, it doesn't matter. So this is dx what? Dy here. So for the x here, you need to use the x is the bound. And for the y's here, you need to use the y's bound here. So the x here, what is here is 0 to 1. And the y is what? 1 to 2, right? Of course, you can switch to a dy dx. Then you just need to be careful. Your bounds need to be a little bit, you need to change to match which variable you integrate. Okay, so now let's take a look. How do we do that? So the first things here, let's move the constants out. So it will be easier for us to do the integration. So you move the constants out. So in here, the bottom will be y cubed. Then this is x plus 2y, right? Okay, so x plus 2y. So this is dx dy. If you want, you can simplify a little bit. And this is 1, 2, this is 0, 1. And then this is the y cube with the x square. And the plus, this is become y square 2x. Correct? Okay, dx dy. Okay, so remember we did this many, many times because you are doing the first is the integration for x. So all the other value except x are constants. So I'm going to integrate here, right? Then the y is just a constant, right? So I don't worry about that. So this is 2, 7. Okay, so this is 1, 2. Okay, so now let's take a look. What is the first integrations here? The first integration will be 3. So this is y cube of the 1 times x cube the 3, right? Because you integrate to the x square. Then plus this is y square 2x, what are your integrations here? So it will be the 2 times 2 to the x squared, right? So 2 can cancel. Then what is the lower bound and the upper bound is 0 and 1, right? So now you finish integrate the dx. So what do you have here? You have a dy remaining, correct? Okay, so now this is 2, 7. Then this is 1, 2. So you put a 1s here. So what is here? So it's 3, 1/3 y cubed, right? Okay, so you put a 1 here and then plus what? 1 over square, right? 1 over y square. Now you do dy because the lower bound 0 will be the same will be disappear. So this is 2/7 here, right? So now you are integrating what? You are integrating for y's here. So I need to integrate for y's here, right? Okay, so now here, this is 1/3. This is y to the -3. So it's a -2, y to the -2, right? Then plus, right? So it's a plus. This is -2. So this will be -1, y to the -1. That's right. Okay. So now, okay, so that's it, right? And then I need to put what? So I need to put the, okay, so put the up bound and the lower bound, right? So it's 1 and the 0. So if you plug that one in, and I did this, it's 15 over 84. I hope my math, I did my addition, subtraction, I plugged the number correct. But anyway, so it's 15 over 84. So you just plug the up bound minus, you plugged in the lower bound, right? So that's it. All right. So the second video is a pretty simple video. So basically, they want to introduce you. So how about if you have more than one random variables, and if you want to find the expected value for more than one random variable. So the concept is exactly the same. For the discrete, then you just add the x and the y together. For the integration, you just integrate the x and the y's, right? And that's it. So the only thing be careful is when you integrate the x and the y, so your limits has to be the, the bound, like the x bound has to match what is defined in the domains. All right, that's it. So it's a pretty easy definitions, right? So the next video, we're going to talk about the moments. So we're going to talk about the first moment, second moment, and what that means here. But here is what we talk about is the expected value. It's the very, very basic fundamental definition about the expected value. Continuous random variable, you integrate, and the discrete, you add, right? So you use your probability, you use the random number, random variables, value times probability added, or you use your random variable times your PDF and then you integrate. All right, that's it. So it's a very short video, and I'm glad we can finish this. So looking forward for our next video. We're going to talk about the moment. All right. All right. Okay. So nice to talk to you. You have a good day. Okay. Bye.